Moving objects. Potential energy is not moving objects. They are stationary objects. When you're seated somewhere, you have potential energy. If I somewhere, see this, now I have this phone at this height. Now when I raise this phone to some other height, it means it has gained potential energy, because potential energy is about the height you gain. From where you are, you go up, you get potential energy. If you go lower, you also have potential energy. So potential energy is the energy by virtue of your position. Energy possessed by a body because of its position, where you are, the position you are in provides you the potential energy. Any source for sound energy?
Teacher.
Sound energy? The what? Sound energy.
Vocal cords.
You can even say loudspeakers. Loudspeakers, now your laptops or phones that you are using, you are hearing what I'm saying because there are those loudspeakers in them that are providing that sound. So sound, anything that is producing sound, any vibrating object.
Lightning.
Okay, we say a vibrating object produces sound. What about solar?
Yeah.
The sun. The sun.
Solar is the sun. Then what about kinetic energy?
Moving objects. Moving objects.
Yes, moving objects. What about chemical energy? Chemical energy.
Fuel and food.
Yes, fuel, food. When you have dry cells, have you ever heard of dry cells?
Yes. The
dry cells are also source of chemical energy. What about batteries? Have you ever seen a battery? The car batteries. Those car batteries are also source of chemical energy. What about electrical energy?
Electric bulbs. Lightning.
Electrical energy comes from what?
Electric bulbs.
Electric bulbs.
Battery.
Electric bulbs are the ones whenever you get that energy, but where does it come from? Okay, some are saying battery. Okay, yes, batteries can also provide electrical energy.
Running water.
Running water. Running water. But does it give us? Running water doesn't give us that. Okay, running water, like at the hydropower stations, Ginger. Those who ever heard of that dam? The running water turns the turbines. It falls on the turbines fall, rotate. When the turbines rotate, then they produce the electrical energy. So running water, I can say hydroelectric power station. What about nuclear? Source of nuclear energy. Who knows the source of nuclear energy?
Radioactive elements.
What?
The radioactive elements.
Okay, the radioactive elements, the atoms of a radioactive element are sources of nuclear. Then magnetic energy.
Magnets.
Okay, magnets, you can say magnets. Now, let me show you this. Let me show you I want to share the screen of this thing. To show you that part of what I'm saying. What are renewable sources of energy? Renewable.
These are sources of energy that can be replaced when they get used up.
The ones that do what? Renewable sources are the ones
that can be replaced when they get used up.
Teacher.
I've not heard what you have said. Renewable sources are the ones that do what?
That can be replaced when they get used up.
Okay, they can be replaced. They can be replaced.
Teacher, can I try?
Yeah, you try.
I don't know how in the system works, but
Can you try? You try. Sylvia.
Renewable sources.
since
My network is not good.
It's okay. We can hear you.
Renewable source is a natural source which will
Which? Okay, so Victoria trying to state something about renewable. Vicky, you are saying something about renewable sources?
Renewable sources of energy are sources which can be replaced when they get used up.
When they get used up. Oh, good. What do you have any? Who can give us? Of course, the opposite is true for non-renewable. This can't be replaced. Now, who can give us examples of renewable sources? Any example under renewable?
Geothermal energy.
Geothermal? I don't want types of energy. I want sources. Sources of energy.
The sun?
The sun. Can we replace the sun? Then biomass.
water.
Biomass can be replaced.
Water body.
Water bodies, running water. Okay,
Wind,
those can be replaced.
moving wind.
Moving wind. Okay, the wind is always there. Even if this wind moves off, there will be some other piece that will come in. All those ones are renewable. We can't say the wind is now finished in the world. We can't say running water is no longer going to be there. So those ones that can always be there are under renewable sources. Don't confuse types of energy with sources of energy. Now, what about non-renewable? Who can tell us those ones that we can't replace? Once they are used up, we can't replace them.
Petroleum oil.
Mineral.
Coal.
The sun.
Nuclear fuel.
Nuclear fuel. Okay. The fuel, by the way, this fuel that we use in the car, when you're running, then the car, and you burn the fuel, then you have to just buy some other fuel.
Petroleum oil.
Okay. Now,
Fuel.
we check what I've shared on the screen. Hey, Belinda is showing something. So we have this part that is on the screen. Can you be checking what's on the screen? The introduction bit, and then the definition of energy. Then we go down to the formulas. Since we discussed this work, we are just going through it faster.
The Bluetooth device is ready to pair. The video model. Aux input model.
The introduction here says, have you ever tried to lift a heavy object such as a jerrycan, but eventually you failed? However, eating food, surprisingly, you were able to lift it. Why do you think you were able to lift it after food? If I ask you that question, why do you think you were able? At first case, you were not able to lift.
You had gained some energy.
You had gained some energy from the food. So the food was the source of energy, the food that you ate. Now, if the food is the source of energy, what type of energy does it give us?
Chemical energy.
Chemical energy.
It gives chemical energy. So that's how I want you to understand the issues. We have the source, and from the source, we get the type. Now, again, they are saying at first you didn't have energy to lift, but after eating, you got the energy to lift. Therefore, energy describes the ability to do work. But where did the energy come from? Food stores chemical energy, and it is this chemical energy that is converted to other forms like kinetic and others. After we are going to look at the forms of energy and conversions. Then we went to the definition. Energy is the ability or capacity to do work. SI units, the joules, capital J. This one we did the other time. Then we go to the sources. These notes are there. I already sent them on your page. So if you want to print. The raw material for the production of energy is called the energy source. There are two types, renewable, these are non-renewable and others. So these are the ones we are starting with right now are non-renewable. These are energy sources which can't be exhausted, which can't be replaced. Non-renewable. When they get used up, examples, fossil fuels. These are from plants that died long ago. Coal, petroleum, natural gas, paraffin, then nuclear fuels. Advantages of non-renewable. Those are the ones down. I want you to be reading through. The non-renewable, those can be replaced when they get used up. They can never get exhausted. The renewable can never get exhausted. For example, if you say they can never get exhausted, the same as saying they can never get used up. Do you think the sun can ever get used up?
No.
Or the running water from rivers, or even the...
So if God says.
If God says, yeah, by the way, if God says, God can, one time God can take away that sun and you see how everybody here will suffer. You start disturbing us with messages on WhatsApp. Hey, where is the sun? What? Okay, the wind can never stop running, or the wind will ever stop blowing. All those ones are under renewable. They can never get used up. The ones that can get used up are the other ones, the fossil fuels. When you use it, it will not come back. If you use the petrol from the car, you have used it already, it has gone away. So you can't say it can never get used up. That's why you keep on buying other liters of fuel. Now I'm giving examples of renewable. They are there. That's what I was saying. Yes, the what? Somebody was asking. Okay, what I was saying, if you print this work, you look at how the work will appear under printed pages. It will be in colored form. But if you have to write these notes, if you have to write the sun, it is not very easy for you to draw the sun and it appears the way it is there. So that's what I was trying to say. If you can print, print. So we have the sun, we have the wind. These are just the examples I've talked about. The running water. Then each time I was writing an example, then I was putting a diagram to represent that example. This is the water running from some river. Who can name that river? Do you know that river?
Action fall.
Action falls, eh? By the way, you senior twos, have you ever visited any falls in your life?
Teacher, yes, in P7, CP falls.
No.
Even
Yes.
P6, even P5. Yeah.
That was under SS.
P7 and P6.
You went to CP Falls.
Yes, teacher. In
You know the
Captain.
Nabisusa Falls.
Which ones are those?
You have never visited Nabisusa Falls.
Yes.
They don't exist.
When you come back, look for me. I'll take you as they are. The Nabisusa Falls. Okay, now these are the forms of energy, all types of energy. Each type of energy, we are putting a diagram to help you understand. To help you understand what we mean. So chemical energy, energy stored in food and fuel. This energy is stored in atoms and molecules of compounds. So I put some dry cells here. And for instance, you have just been born. You are born like in 2015. You don't know these types of dry cells. These everett, they were there before. I don't know that they are still there. But everett, they were some of the dry cells that came onto the market sometime back. Then the nuclear energy, these are nuclear plants. Those countries that produce nuclear energy, this is how they design those plants that produce the energy. There's a lot of smoke that comes out of the plant. Produce them. They can use nuclear energy for.
Why do they design them with smiley faces?
Hey, they
And
are
yet
smiling.
nuclear is dangerous.
It pollutes the world.
You make people feel it's not dangerous. Well, what do you say is dangerous? Nuclear can provide electricity.
Yes,
But
teacher, but also causes pollution with smoke.
Yeah, because they are true.
And
Because
people
of
bomb each
pollution.
other with the nuclear bombs.
They bomb each other. They will be defending.
Teacher,
They will
they
be defending
produce
themselves.
toxins that kill.
But teacher, the environment.
Yeah, the environmental factors are so much affected here because there's too much smoke. That's why they are all constructed in places with very few. Actually, nobody should be staying near those areas. Those big countries that have a lot of space.
Teacher, and the workers?
The workers get protective gears. They put on clothes which are protective. Of course, in the long run, they also get affected and die. And dying is natural. At some stage, you have to die.
Yes, teacher.
Then electrical energy. This is from electricity. I put somebody trying to connect up electricity there.
Teacher, in those cartoons.
These are not cartoons. These are real people. Okay, that guy is my friend. This one on the right.
Chatwa is Amuri.
Teacher, those look like game graphics.
These are real people connecting electricity near
Mama, like people in
Teacher,
video
they look
games.
like game graphics.
How did you see the face when it's so tiny and
My camera was not good that time. I took a live picture.
Wow.
Then the light energy, these bulbs in your rooms. These ones can be different bulbs. They can have these energy savers, the normal fluorescent tubes, any, as long as this energy. Because we are saying light energy, this is the form of energy which enables us to see. So anything that helps you to see is under light energy. Then the radiant energy, energy from the sun, radiations. So you see, now drawing these diagrams will be hard. You just take the pages and print. And printing colored is better. But if you can't, don't force your parents to print for you when they cannot. I know you students will say, teacher said you should print. Then you go to WhatsApp and start putting. Should we print? No, don't print. Teacher said don't print. Then you.
I think teacher got fed up of those questions.
People who are not in this class always disturb us on the platform. They get information which is not fully packaged, then they start asking, children, should we do this? No way. Mom. So there is heat energy is there. That is results from movements. the body. It can be from the fire, like what somebody said, from fuels. And it can also be under heat energy.
From
Then
the
sound
sun.
energy, the DJs. Some of you pretend to be DJs at home. Those loudspeakers that you use are under sound energy.
But we are DJs.
Yeah, some DJs there playing a guitar. And then we have some fireworks. Even when the fireworks are produced, there is that sound they make in the process of starting them. So some of you who are not ever sleeping on New Year's Day, I know most of you are sleeping, but first who are ever awake, fireworks are produced like at big hotels, but they make sound. Even me, I always produce fireworks because I have a source here.
Oh,
They make
please.
banda.
Yeah. This will be overnight.
Teacher, spare us
After not
the
always
line.
in Nabisunsa, I would have noticed. If you stand near Banda, you could see Ochambogo. The only person who is allowed to produce them.
The last New Year's they refused fireworks.
I was given permission.
Take away. Those are big lights.
Geothermal energy. Energy from the underground.
We never saw.
I thought you stand near Nabisunsa.
Yes.
Yes.
I'm just next to the gate.
Yeah, but you are sleeping that time.
I even saw you.
Okay, the geothermal, every time you see the word geo in physics or in general science, when you see the word geo means underground, the earth. Geothermal, some people are going to do geophysics, that is study of the earth crust. Geo means the earth, and when you say geothermal energy, you know thermal means heat. So the heat from the underground forms energy. Those are sources of the earthquakes and other things. So that's what you're saying, geothermal. Then mechanical energy, your kinetic and potential is placed under these two. Mechanical energy is the one that has the two forms of kinetic and potential energy. With mechanical energy, you add both kinetic plus potential. Here I'm trying to put things that demonstrate those energies, the two types. I put some springs. The springs, when you compress a spring or you make it elastic, you extend it sideways or you compress it. That spring has, when you compress, it has potential energy. When you release it, it will go back to its normal shape. It will give off that potential energy. So potential energy is under springs. We normally call it the elastic potential energy. Then we have this plane. By the way, this plane flying at some height has both kinetic because it is moving. It also has potential because it is at certain height. Remember from the formulas, potential energy was mgh. There was that letter h. So h means any height from the level that you want to refer to. For example, if you take the level ground as your reference, any height, this plane is above that reference. If it is above, then it has potential energy. At the same time, it is moving. If it is moving, then it has kinetic. So it has both kinetic and potential. Then this electric train, the electric train is moving. So it has kinetic energy. Then the simple pendulum.
Are those planes there in those trains in Uganda?
So they are not yet in Uganda, but the government is planning to do so. By the time you reach senior 4, we shall have them. Senior 3 second term. Actually, I go to senior 3 in August.
Teacher, already in senior 3.
Teacher, already in senior 3, so.
Teacher, when shall we be in Form 3? You guys don't lie to yourselves. You're still in Form 2. Form 2
you're in Form 2 and we are doing this syllabus. I just pity people who are. I pity people who are not studying online, because now we are studying topics that we'll be studying in senior 2. So first we shall promote people who have studied the next class. Okay, the simple
Teacher,
pendulum.
people
Now,
are savage. Some people may not be able to afford Bambi.
yeah, we are not saying that. We just pity them. We are not blaming them. Tubasasira bambi.
Bambi. Jesus.
Yeah, munange bambi.
Teacher,
They
you
should
no
also
joke.
develop to attend.
Jesus Christ, Naisonsa has to improve. Now those people that haven't paid, those people that aren't attending, what will they do?
The teachers are going to repeat this work. Just because when they repeat the work, teachers might be a little bit fast. Some topics will just be done under revision. That's the challenge that will be there. But they will repeat. God will help them. They will understand also. We'll keep on praying.
Typing doesn't work.
What happens to that 1.3 we paid? Why don't you use it to pay for our Zoom lessons?
No, it is there.
They've said that 1.3 is going to be our school fees the next time we report to school.
When you come back,
we are not going to pay.
Yeah, you're not going to pay. Your money is intact. It is there properly.
Okay.
You can even ask some of it to have, to have some fun.
Yeah.
No, your money is intact. That's why we didn't want to disturb you again paying for, using that money for Zoom. We ask people to pay different money for Zoom, such that their school fees is there.
If government had said we are allowed to pay fees, then we would not pay for Zoom classes. They would be free. They would be using our school fees money.
Like last holiday, there was some holiday we didn't make people pay for the Zoom. There's a math, the senior ones, 3 and 5s. When you're marking, you never in our school. They never paid because their money was still there. Okay. I wanted most.
Okay, teacher.
The calculations that involve kinetic energy. I remember Mr. Byman told me he discussed with you this formula, a half mv squared. You remember that formula?
Yes, he did. Yes.
Where m is for mass.
Yes,
and v is for velocity. Velocity means speed. Just because at some stage we call it velocity, we shall discuss it in motion, but you just know that whenever you talk about velocity, it's the same as speed. And now we have that example there. Should we go through the examples you did? Yeah? You did some examples with him the other time, isn't it?
No, teacher, they told us those are for, I think, Form 4. We shouldn't stress our heads.
We can go through it. Okay, you look at that number, example 1. Let us go through that example 1. You first write it down somewhere, then I discuss it out. Example 1. You should be able to do these examples. Find the kinetic energy of a body of mass. The body has a mass. The body has a mass of 2 kilograms. And a body of mass 2 kilograms, then moving at a speed of 4 meters per second. Now, we have just said if they ask you for kinetic energy, the formula is very simple. Kinetic energy, the formula is a half times mass. We normally just say a half mv squared. You can ignore the symbols of multiplication. A half mv squared. When we say a half mv squared, our target now is to substitute in. Where you have letter m, we replace it with mass, 2 kilograms. So times 2. Where you have v is the speed, and the total speed is 4 meters per second. So we put here 4 squared. 4 squared is the same as 16. So we have, when you simplify this, this 2 can go with this, and 4 squared is 16. Then don't forget the units. Energy is measured in joules. So you put 16 joules. So the formula is very simple. You can always use it. You can use it to work out numbers under kinetic energy. Are we together? You always check for the mass. By the way, if the mass is not in kilograms, always convert kilograms to gram. I mean, always convert those grams to kilograms. Mass should always be in kilograms. Then you copy that part 2. Part 2, Mansul of mass. I think now you can easily work out that one. Mansul of mass 60 kilograms is running at a speed of 10 meters per second. Just copy, you do it later. My battery is running so fast. You do it later. I want us to look at. And by the way, this assessment, there is assessment down. Assessment exercise, I will leave it for you. That's only 3 questions. Hey, you hadn't copied the other one, eh?
Teacher, let's copy the exercise.
Can somebody take a screenshot and send it? Cynthia, can you take a screenshot?
Yeah.
You help us take a screenshot and send on our page, eh? Because I want to go to potential energy calculations. And my battery is running so fast.
Okay.
Please, when you get this exercise, you work it out and send your work to my inbox. The other time, only 3 girls sent work out of 50. Please, you send that work on my inbox. Sylvia, you have taken a screenshot.
Yeah.
Have you? You will send it on the page. Eh?
Teacher, I've already sent.
Oh, good, very nice. Now we go to potential energy. By the way, I saw people who had shared our link. There are some other 3 girls we are looking for who shared the link. We want to stop them from attending class. Don't share the links. The system can easily detect whoever has shared the link. This link is to whoever has paid money, because we are also paying to the Zoom accounts, and I can easily organize. Okay, potential energy is that thing that you see there. The energy possessed by a body due to its position. I've been reminded. Please write your real names. Don't use iPhone 7. Don't use Samsung. Don't use other names like Tiki Tiki. Use your real names. 2 names, Sendaula, Ibrahim. Don't just say Ibra. Eh? Put your real 2 names or 3 names. And if you have 7, put them all. Okay, potential energy is what you are seeing there. I was giving an example. Eh? How many in school year? How many use decas? Oh, Gift is asking some question. Gift.
Everyone sleeps in a deck.
Okay, in school, do you sleep on decas? Do you sleep on decas? Like double decker?
Yes.
Okay, who has more energy?
Everyone.
When you are sleeping, somebody is in the lower decker and some other person in the upper decker. Which energy do you have when you are sleeping?
Potential energy. Potential energy.
You have potential energy.
energy.
Now, the person who is sleeping in the lower decker and the one in the upper decker, who has more potential energy?
The one who is on the upper decker.
Yes, somebody is here and another person is here. So this is the decker. This is the ground. Now the height, if this is, for example, 1 meter, and this one is 3 meters. Can we say 3 or 2? 2 meters. Okay, 3. Somebody is at 1 meter. This person is at 3 meters. Now, the one potential energy, it has a formula, mass. I'm assuming our mass is the same. Our mass is 30 kilograms. So if you are to get the potential energy for this person 1, for person A, and person B, for potential energy of A is mass GH. The mass is 30. Then what do we get there? Here we get 300. This is for the person A. This person, because of the height. Height is 1 meter. If I were to get the potential energy of person B, potential energy of B, mgh, we shall have mass is, I'm assuming that the mass is the same. You guys have the same mass. You all good way. Where koza? 3. The height, this height is 3. The height we use in this formula is height from the ground going up, is vertical height, not any other height. So here you end up with 900 joules. So this guy here who is sleeping up here has more energy. If this guy lands on you, if somebody sleeps and you end up falling down, when this guy finds you down and they fail on you, you get a lot of, your bones can break because they have a lot of energy. They transfer that energy onto you down. So potential energy is basically about the height from the ground. The formula is mass. G is always 10. G is a standard 10. You don't change it at any stage. Okay. So when you check, the formula is there. I'm trying to put out some worked out examples. Let me also, these are examples. I want us to take a screenshot also and post them on your, let us first look at this. Let us first take the screenshot of the exercise. Somebody help me take the screenshot of that exercise. Then you post it there. There are only 2 numbers. Then we come back and look at the examples. Who is taking the screenshot? Is there any person taking the screenshot? Of that assessment? You have taken it? The 2 numbers about potential energy. Okay, now those are the examples. Numbers of mass 80 kilograms. Do you believe numbers are, not your teacher, numbers are, one of you is called numbers. Is there any student with 80 kilograms?
Yes, Chami.
Okay. If you are 80 kilograms, then your height should also be in comparison to the weight, such that if you're not comparable, then you go to some exercises, you go for aerobics. And when I said people come for aerobics, very few people came from senior 2. Senior 2 want to do very stubborn.
There were many people.
Teacher,
There were many people.
You are new people.
Some of us didn't want.
Distancing,
it was just open, free for any person who wants to do some little shake up.
We are reading books.
We're busy.
You are reading books for our exams.
And you can't read books when you don't have anybody's not helping.
Teacher, that's what you say, but when we fail, hey.
You cannot fail when you do exercises. Because you read exercises, you read with a sober mind. Your minds are not tired.
Those are your excuses.
Just know we didn't want.
And you, because you don't know the benefit.
Want period flat.
You didn't know the benefit of exercises. Okay, we are checking that number one.
We will
all
all
these
die
examples, all the examples are about using the MGH. So, if somebody can take a screenshot, you can take a screenshot and also read them after, because we are just repeating the same things. They are giving height and mass from the ground, height from the ground. I want us to go to the next part of energy transformations. Has somebody taken a screenshot and posted on your page?
Yes.
Now we want only to see academics information on the page, not those other things of asking. I tell people quarrel. Two girls were calling over a boy.
But teacher, that's
I will resend. I will show you. Then I said, "Oh, this one, what has happened?" And the boy was keeping quiet. For him, he had posted something small, then he kept quiet.
Just make another group and you teachers go away from that one.
That will be best. That's the best option. You make your, and this page has parents, it has teachers, it has administrators, it has other people from different schools. And when people start discussing that, they assume it's only the Bisusa girls.
That one.
You make another group and you share your own information. Okay.
That already has many numbers.
But you can transfer them. I will show you how they transfer numbers. You inbox me.
Okay. Okay.
So energy transformations, energy can neither be created. It's just converted from one form to another.
Auntie, how will we know which
one, Dad? We said energy can be transformed. You see that one? Devices used in energy conversations. When you put, do you have a torch? Have you ever seen a torch?
Yes.
There are some torches that use dry cells. When you put dry cells in a torch, what energy do we get from dry cells?
Chemical energy.
How we get chemical energy. But what does the torch provide us with?
Light energy.
Light energy. So it means the chemical energy is converted into light energy. Using a torch. So a torch becomes a device in that case. That's what we are talking about here. But in the process, some energy is for example, the energy dissipated into the surrounding. Some energy is lost into the surrounding. So these diagrams here are just diagrams showing devices that help us convert from one form to another form. So there is a torch, it converts chemical to light. We have batteries, the ones in the car, they convert chemical to electrical. You know, actually these ones convert so many things, to electrical, to mechanical, even mechanical, because when I'm driving the car, when I drive the car, it means it has gained kinetic energy. So the energy came from the batteries and then it was started. Then we have the solar panels. How many of you have solar panels at home? Are using solar panels?
Me.
Okay. So those solar panels convert the light from the sun to, of course, there are some other things we have not talked about here, but we just say light to electrical. Then the bulbs, electrical to light, flat iron.
Electrical to
Flat
heat.
iron converts electrical to heat. Then the cooker, electrical to heat. We have the temperature gun.
Temperature
This is a temperature gun. And now these days we brought in others which are where we just sense without you people touching. But these digital thermometers or temperature guns convert heat to electrical. So all these diagrams, it's very hard for you to write them. Printing becomes very good for you. Loudspeakers, electrical to sound. Like the small DJ girl here, putting on microphones, sound electrical. These are just simple versions, but there are other forms the same devices can change. Electric motors, a dynamo. These are called dynamos. Then the generator. Some people know generators. Kinetic to electric. Kinetic is like mechanical. The toaster. How many use toasters? Very few.
As teacher.
Me, teacher.
So the toasters convert electrical to thermal.
Teacher here.
Some of you have used them this morning.
Yeah.
There are so many of these examples that I placed. There's this blender, there's this guy who is eating food. Then the neutral. Oh, so that I was saying that if you print, you can easily see the colored pictures and this information. The lawnmower, mechanical to electrical, windmill, mechanical to electrical. So many other things can help you here. Then down, I try to put some conversions. I put examples, the energy conversion of hydroelectric power station. At the hydroelectric power station, the potential energy of water in the waterfall. The water falls from some height. We are saying it has potential energy because that water is at a certain height before it falls down. That's why they are calling it a fall. Falls. So when it is up there before it falls, it has potential. In the process of falling down, it gains kinetic. Then when it falls on the turbines to rotate them, now rotation is also kinetic. Then finally, when they rotate, they finally give us the electrical energy from the station. That's why we are talking. That's the series of how energy is converted at the power station. Now I gave out some example of a falling stone. There is a stone falling from a certain height. Now before it falls, the stone has potential energy, maximum potential energy. As the stone drops down, in the process of dropping down, my battery is running out. It changes kinetic to potential. Changes potential to kinetic. But here, because it is still at some height from the ground, if it's at some height, it has both potential and kinetic. The potential is because it has some height. The kinetic is because it is falling speed. Now when it reaches down, here we say it doesn't have any potential energy. By the way, why doesn't it have any potential energy here at the ground? Why is potential energy equal to 0? Who can tell us that at this point?
It has reached the ground.
Because, after reaching the ground, the height is 0. So there is no height at the ground. Therefore, its potential energy is 0. Now, at the beginning, we said its kinetic energy was 0. Why did we say kinetic energy was 0 at the first point up?
Because it's not moving.
Because it was not moving. So if it had potential energy maximum, now that the entire potential energy has now converted to kinetic energy at the ground. That's why we say that energy is just converted. We don't lose it. Neither do we create it. If it had 20 joules up in form of potential, it will have 20 joules down in form of kinetic. But in here, if it is halfway, it you have 10, 10. 10 potential, 10 kinetic. Something like that. They can give you this number in terms of a calculation. Now, I gave examples here. My battery has very few minutes. The battery didn't charge well. Somebody help us take this screenshot and post it there. All these screenshots have numbers that you're going to try. You take a screenshot because I might not be able to finish up these minutes. The battery is getting done. I'm going to get another laptop to finish, but for this information, because it is on this laptop, first take a screenshot and post it. In that your friends who are not here can also have some bit of work. You tell them to pay you to discuss for them. Have you taken a screenshot?
Someone can become.
How is Peru the host now? You guys, where is teacher?
And then shut up. People, why are you being mean?
He said he's going to get his another laptop.
Who is iPhone 8?
Man,
Dad. Ma, how you asking?
We don't actually have that.
Dad.
Gwen no shop.
iPhone 8. Techno.
Condolence.
Matina.
Yes, some of us.
Yes,
Condolence.
Yes.
People, can you stop making work? Mr. Sendaula is logging
you
now. People, can you keep quiet? Mr. Sendaula is logging. Mr. Sendaula is logging in right now. His battery got some issues, so now he's connecting to another laptop. So just be patient.
Good morning, teacher.
Good morning. How are you?
We are fine.
We are fine.
Teacher.
We are fine, thank you.
We are fine. We are fine.
Teacher, there's something up there.
Teacher, are you under the desk?
Tenaka later. Later HD webcam. Hey.
Your camera looks
weird.
Learn to buy for him.
He's using a phone.
Peru.
Yes, Rona.
Mute.
We can't hear you.
Manya, you're muted.
You're muted.
Teacher, you're muted.
Teacher, you're muted.
Teacher, we can't hear you. You muted yourself, yet is a host.
Teacher, you're muted. We cannot hear you.
Teacher, you're muted.
Teacher, you're muted.
You are muted.
Continuing
to explain.
Teacher,
Teacher, you're muted.
Abana bagamba naye
But he's not talking.
Do something.
Teacher.
Put up their hands.
Oh dear.
But yours is open now.
And the guy is continuing to explain.
Teacher, you're muted.
We cannot
What's the
hear
formula
you.
for potential energy for this number? We have put it here. When we substitute in, what do we get?
1,200.
Can we substitute into this formula? Hello?
We get 1,200 joules.
Yes, teacher, we are getting you.
What's wrong with the sound of this laptop?
1,200.
1,200.
1,200.
1,200.
The Bluetooth device is ready to pair. The radio model. Aux input model.
Hello? Can somebody speak and text the microphone?
Yes, teacher.
Teacher, it's 1,200 joules.
1,200.
These speakers. Okay, you can hear me?
Yeah.
Yes.
Teacher.
No.
Yes, teacher.
Okay.
Yes.
So this stone is of 1 kilogram mass and is released from rest. The word rest means it was zero speed. It wasn't moving. So if they ask for the potential energy before it begins to fall, then you substitute in what you have. Mass is 1 kilogram, the G is 10, and the height is 120. What do you get?
1,200.
1,200. 1,200.
1,200.
That is part A. Now in part B, this work is on a screenshotted part on the page. Part B, if the stone falls with a velocity of 2 meters per second, find its kinetic energy. If the stone falls with a velocity of 2 meters per second, find its kinetic energy. What is the formula for kinetic energy?
a half mv squared.
Yes, so we shall put a half times 1 times 2 squared, which is 4 out of 2, giving us
2 joule.
Excuse me, teacher.
Yes.
What is V?
V is velocity. We said V is velocity, which is the same as speed. You can either use speed or they use velocity.
Excuse me, teacher.
Yes. Somebody is asking.
Where did you get the speed?
In the question, they say if the stone falls with velocity of 2 meters per second, we said velocity of, in the question is there. You check the question, there is this statement. The stone falls with a velocity of 2 meters per second means speed. So you have to put there that this squared, it's also squared. Then part 3 is what I want.
Teacher, first aid.
Are you saying?
Yeah, you ask. You are copying
When
the one.
you write speed squared.
Okay, this letter V is the same as speed, so you can write speed squared. Just because in this level, the level you are discussing, you know, I don't use the word speed. We use velocity because it has a direction. When the stone is falling from up coming down, there is a direction. Whenever your speed has a direction, then we don't call it speed, we call it velocity. When you discuss this work in motion, so for this case, whenever you see the word velocity, it means speed with a direction. Yes. Someone was asking. Gift, I guess I give what you want to ask. I can't get what you're saying. There are so many vibrations. Other people, can you gift?
I was just.
Can Lucy, can you please mute? And Melanie and Lucy. So now Gift, can Gift ask, Gift, what was your question?
I was asking if you can do the work on our page because our network is bad.
We have already posted it there.
No, like from sources of energy.
No, that one just download because I already put the notes, the entire package for the whole notes, work, energy, and power is there on the WhatsApp. You didn't see it?
Yeah.
It is there. Okay, I'm just going. I'm just going through that. And that's what I was saying. If you want to print it out in color printer or you copy it, whatever you want. But when you do it, you don't have to repeat when you come back to school. That's what I was trying to say. Okay, they're asking for the velocity. Part C is what I want to discuss most. Find the velocity with which it hits the ground. Can somebody share the screen? Somebody share the screen of the question.
Okay.
Find the velocity with which it hits the ground. As it hits the ground, what velocity does it have? Yes, so how shall we find the velocity? How shall we find the velocity which it is the ground? Okay, now the simplest way is this. From what we have just said, we have just said that when this stone is here, it has potential energy. When it is on the ground, immediately it falls here, it has kinetic energy. When it's here, it has potential, but the kinetic, 0. When it is here, it has kinetic, but the potential is 0. Be careful what I'm trying to say now. At the top, it has 0 kinetic. At the bottom, it has 0 potential. Now somebody can ask you, now the potential that we had up, if this one was 10, what would be the kinetic down? If it was 10 joules up, what would be the kinetic down?
10.
Then whatever it had up is what it maintains down. It is what it retains. So what we can say that the potential energy lost is equal to the kinetic energy gained. Okay, let us write it the other way around. Let us say the kinetic at the ground, the kinetic energy gained is equal to the potential energy that we lost. Whatever we lost, all the 10 that we lost that was potential, it has been gained as kinetic energy. So we start by writing that the kinetic energy we have gained is equal to the potential energy that we lost. Now bring in the formulas. What are the formulas? Kinetic energy, its formula is a half mv squared. That is kinetic energy formula. Then what is the formula for potential energy? mgh. This side we have kinetic energy that we have gained. This side we have potential energy that we have lost. Now let us use mathematics. Do you agree? Now I don't know what we can I divide by m on both sides?
Yes.
It's common, eh? So this m can go in. So we can remain with this. The m's cancel because it is on both sides. Eh? Do you know the question they're asking for? They're asking for the velocity. And in our formula, velocity is this letter v. V is the velocity. So what can I do now to get velocity? From where I have this.
Multiply 2 on both sides.
Can multiply 2 on both sides. Very nice mathematician. You'll be a very great mathematician. But physics is the queen of science. So v squared is equal to 2bh. Do you agree with that formula?
Yes. Yes.
So from that formula, we substitute in what they have given us. When we substitute in, that's why, by the way, how do I remove this square on that v? What can I do to move that square?
You find the square root on both sides.
Square root.
You put the square root. What square root? Square root. Here you put a square root. Also here you put a square root. So v is square root. Square root. So at that stage, you can substitute in. Gift audio. Gift Can you mute? Baby gift mute. I can't even hear anything. 20 table. What you get when you multiply?
Under root.
So what is the square root? With calculators, what is the square root?
48.99.
48.99. What are the units? What are the units?
1 minute meters per second.
Okay, so gift mute. Different. If I can mute. Okay, very nice. Somebody was asking, why did we divide by this letter M? We divided because we wanted to simplify the expressions. When you find a letter common on both sides, mathematically, you can divide that letter through, you can cancel it. So there was no reason of maintaining the M, yet it is on both sides. So you just divide it. For example, if you have a number like this, if you have 2x is equal to 4, how do you get x? You divide by 2 because it can be on both sides. So you divide to simplify what you have. Any other question about this solution? Martha?
Excuse me, teacher.
Yes, Elizabeth?
Like if they ask this question, do we have to show all this stuff that I have, how the M goes, how the, squared goes? Do we have to show it?
What you need to do is just write this statement because it's a physics statement. Kinetic energy gained is equal to potential energy lost. Then you put there this formula, the two formulas on either side. But now you might not need to divide. From these ones, you can go direct to this. You can even go to this direct. You can go to this. You can even ignore these two. Because first in science, after putting this and this, then the rest is mathematics. Mathematics tells us from these two, we can come to this formula. So here I was just trying to show, because sometimes they can ask you to derive to show that this V is equal to this. When they ask you to derive, if it's not a calculation, then you have to show like this kind of work. But the most important, when you are giving a mark, you give a mark to the statement of telling us energy conservation, that energy is not lost, but we just change it. So you give a mark to this, we shall give a mark to the formulas. Formulas, then we give a mark. Okay, when you reach here, you just go to this. Because even this is got from the formula, the expressions. So we just go to the final thing here, we give a mark of substitution and a mark to this. Please,
okay,
teacher.
Teacher.
Yes?
I can teacher. Write other questions.
You did what?
Write other questions that like we can use that formula.
Hey, and now but let us create another formula. Let us create a question ourselves. Let us say You copy this question.
My battery is off.
That's okay. That's all right.
I was thinking you cannot see me.
Hey.
Where are you for now?
Eight questions.
Excuse me, teacher.
Yes.
I was asking in that question. I can't see the mass.
Can't see the mass. Eh?
Yes.
I didn't mass. Hey, okay, a box. Let us do this. Let me just add the mass here up. Everybody add this mass. A box of mass 15. Let us see with 20.
Teacher, how much is the mass? I can't see it up there.
It's too high up.
20. You have now seen it.
Yes.
Teacher.
Teacher, we cannot see the down part.
One. So you try that question also, you send it to me in my inbox.
Send you the answer.
Questions. I have not put answers, I've just put it open. You just send, because I've not worked it out. Just use the formulas.
Questions.
Now, Kabira, your hand is up. Hey, Lisa, we said the mass was 20 kilograms. You didn't write it. Mass is 20 kilograms. A box of mass 20 kilograms.
Teacher.
Now, Kabira, saying what?
Excuse me.
Yes, no excuse me.
Teacher.
Now, Kabira, ask your question. Your network, you type it in the message. Vicky, you are saying some question? Stacy, I see you. I think your audio, I don't know what's happening. Your sound is not coming out. I can see your audio is moving up, but I can't hear the sound. Victoria, you just...
So the lesson is done.
Yes, the lesson is done. After copying this, lesson is done. You are finished.
Bye.
Just screenshot.
See the mass. Yes,
Teacher,
teacher, I can't see. I said they can't see.
They can't see what? The mass,
The mass is 20 kg.
20.
Teacher, what are we doing with those numbers? I thought we were going to discuss them because some of them are not, we don't even know them.
We have just been discussing.
You mean this is
height stands for velocity. Teacher.
When
the height stands for the velocity. Condolence.
Yes.
Excuse me, teacher.
Teacher, the height stands for the velocity.
Velocity.
Teacher.
Height is not velocity.
I'm stuck.
Excuse me, teacher.
Teacher, are you sure we have discussed all that question?
Mom, stuck.
How do we find velocity?
Teacher, I thought you're going to discuss. We didn't discuss all those.
Roman number 2, kinetic energy before it is released.
What is that energy before it is released? Who can tell us that answer? Kinetic energy.
Nanti, a half mv squared. Then a half times 20 times v squared. What do we put in place of?
Look at what I'm doing.
At least you do.
Roman number 2.
It's 0.
Very good. Very nice. The one who has said 0, I'll buy it for you. Apart when you come back.
Mama, thank you, teacher. Now we understand.
These numbers are just checking what that's in the previous question.
Teacher,
what is 0?
Now these ones for halfway. Halfway when 0 is the velocity. Teacher, now the one for halfway when it is released. halfway released.
20 meters. So you first get the potential energy, then whatever potential energy would have converted to the other one, to kinetic. You just equate them. Equate the two potentials to kinetic. No, they will be the last number in the previous question.
Teacher, write on the board.
On the board.
All the stages you are going to say potential energy lost is equal to kinetic energy gain. All these numbers, you are going to write this. Then you put the formula.
Okay.
You put the half.
Okay, teacher, now we have understood.
Halfway. What is the height for halfway? Height. It is 20. This one was 40. So height will be 20, isn't it? Half 20.
Yes.
So it means you put here your mass, your G, and the 20. Whatever you have here is the answer for kinetic. Because what you have lost is what you have gained. In that case, you don't put the half on this. You just put the kinetic energy gain is equal to potential energy lost. So what have we lost? We have lost mass, we have it, we have G, we have that 20. Halfway means 20. So that would be just the answer in that. You don't even need the velocity in that number.
Okay.
Okay, Carly.
Teacher.
Teacher,
on that one, halfway the building. At velocity, we get 20, which is 40 divided by 2.
That is height. That is height. You don't need to get the velocity. Just get the answer for this side of potential energy. That is the answer they're asking for. Whatever you get is the answer. Whatever you get is the answer.
Stop making noise.
Wait, I have not put this thing, the velocity. Velocity as it lands on the ground. Because it was on the other part. Let me make it as your last part. Velocity as it lands. That is what I ordered most. I've just forgotten it. Velocity as it lands. You see that the other previous number we have just done is you add it there. Velocity as it lands. You have to go to the chapter.
Teacher, you're very.
You guys, stop laughing in our ears.
Understand this one. Okay. See you at 11:30.
Bye, teacher. Thank you for teaching us.
You're not teaching math.
Teacher, first give us the answers to check.
Teacher, you're the one teaching math.
Senior 2 want me to come back and then people will say on the page, and it's the same guy coming all the time.
Hey, teacher. Let me go and ask my friend Kuranga. You have not explained.
The other time people said, but it's physics all the time. And I said, these girls.
Yeah,
teacher, bye.
Bye, teacher. Thank you.
Have a very good one.
I'm still